Merlin, Network Magic, Deep Dive, Show Interfaces. Hey everybody, John Capobianco here, the lead developer of the open source project Merlin. And my big release I've been working on is for NXOS, for Nexus in the data center. So today, building on the introduction video, and I recommend if you've started here, go back and watch the introduction that gives the high level. I'm going to do a deeper dive, and this is a great opportunity because it's such a valuable and important command, and it really is going to seem like magic. That's the whole deal around Merlin, that we can connect, run the command, parse the command, and then get JavaScript object notation, JSON back. And then from there, we can do all kinds of great things. So let's quickly show you what I'm talking about here, right? So in this data center we're going to be looking at, there's a pair of Nexus 9Ks, right? And these have interswitch links, and these connect with port channels to 2K FEX, fabric extenders. That's one data center that we'll be looking at. And another data center is a little bit more of a traditional data center where we actually have 7Ks linking to 5Ks. Now, unfortunately, I've come to find that this particular command does not parse on the 5Ks, which is unfortunate, and I'll be sending that upstream to the development team. So we're going to be focusing on really this 9K environment because it has the FEX as a more traditional access layer where things connect, right? Important things. Now, in the world of networking, if anyone's new or studying your CCNA or your CCNP or your DevNet associate, anything like that, the data center is the highest concentration of interfaces in the entire enterprise, even out on the campus. Now, a traditional campus, yes, there can be stacks at the access layer of 8 or 9 48 port switches. But in the data center, right, per rack, traditionally, there's 24 to 48 ports per rack at a minimum. Now, when I talk about 2K fabric extenders, for anyone who's not familiar with this term, it's important to point something out. These are like virtual line cards in the parent Nexus 9K or 7K or 5K, where the control plane and the management plane is at the parent 975K, and the data plane is distributed along remote fabric extenders, which are traditionally your top of rack access layer switches for your rack, and then you'd have your 5, 7, depending on what it is, either end of row or middle of row or something like that, and then you just have one management plane to deal with. The other thing I want to point out is in the data center, typically, right, we want redundancy or high availability, so there's going to be an A and a B side with HSRP or a first hop redundancy protocol providing that virtual IP address for default gateways out of the data center. It's not a stacked environment like the enterprise with virtual switch stacking or things like that, right? These are truly A and B that we have to make highly available. So let's take a look at the code and let's get right into it. So I'm just going to show you again, let's run this with the time command, and then we'll jump over to the output that I have pre-canned. Now this is going to seem like it's going to take a while, but you have to remember it's going interface by interface, and interface is a broad term. This is not just physical interfaces, it's SVIs, it's tunnel interfaces, it's loopback interfaces, there's lots of management interface, right? Lots of different interfaces. So this is just going to, and this can all be suppressed if you don't want the screen output, if you just want it to run like CPU time in a couple of seconds, right? The ASCII can be stripped away, PyATS can be configured to be silent, and then it just runs. So it's just going to run here in the background, and let's take a look at what we get from the output. Now let me close this file for now. Now this, what you're looking at here on the screen, is the JavaScript object notation representation of that show interface command. Now I've gone ahead and stripped it down to have a physical interface, a couple of virtual interfaces, right? I include VLAN1 in case it's special. I'll loop back the management and a port channel. Now I don't have any tunnel interfaces or any other types of interfaces, but with this rich data set, let's look at a physical interface. Now already you can see the advantage of working with infrastructure as code, right? Do you want to work with this output on the screen? Like look at it just scrolling and scrolling and scrolling. Yes, you can use filters at the CLI and pipe your way in to begin at a certain interface or something. But this, what you're seeing dumping here on the screen, has been the traditional output that network engineers have had to work with for 30 years now. Just, it's very rich on the NXOS, as we'll see. But imagine if I could run this command and then deal with this data in business-ready documentation. Even the JavaScript alone, as you can see, I can collapse, I can find the interface I want and go look at the information. Now, I'll show you what I'm going to do with this JavaScript, but let's explore it for a second. Now, you can see these have bands and they're highlighted. I've collapsed these. So we get what? The admin state. Let's just talk about the important ones. We get auto MDIX. Bandwidth, is the beacon light on? Is it a dedicated interface? The delay, the description, the duplex, the efficient Ethernet enabled, and then encapsulation, right? We get that it's ARPA. The ether type in hex. The flow control, send and receive, it's not turned on, right? False and false. This interface has been reset 7 times. It last flapped 10 weeks ago. Well, what happened 10 weeks ago, right? That's something I'd like to investigate. Why did this flap 10 weeks and 6 days ago? Its link state is up. It's got a MAC. It's a 40 gig media type. It's broadcast medium. It's got a 1500 MTU, which is interesting in the data center. I was expecting that to be a jumbo. The Opera status is up, the physical address, and then the port channel information. Yes, this is a member, true, of port channel 48. It's a trunk. Its speed is 10. The reliability, the RX load, the switch port monitor is off, transmit load, and the type. Now, I've intentionally left counters to the end. Look at all the counter information that we have. Now, I'm not going to go over all of them, but we got broadcasts, CRCs, discards, errors, multicast packets, input packets, the last time the counters were cleared, and then the output version of all these packets. We even get the rate, right? So we could sample this and build graphs, build charts, which interface has the most, right? We can do incredible things with this. I'm going to show you some simple things to start with. Now, is it finished? Okay, so here is the Pi ATS, and I know I'm successful because I have my little Camelot ASCII here that gives you directions on how to see the log and how to get into the folder. Now, every test, again, I filtered out the 5K platform, but it parsed it and it stored the data across all of these steps, and they've all passed. It took 2 seconds in CPU time. Now, yeah, it took 2 minutes to run. 2 minutes isn't really a big deal with all the output, but 2 seconds. I could sample this just almost continuously in a container and just infinitely loop it, or run it in Espresso every X number of seconds or minutes or whatever cadence I want, and build those graphs, charts, Grafana, whatever you want to do with it. Now, here's what I'm going to do with it. So now I have the output, and I have it for all the different types, the different variations, right? Physical, virtual, loopback, management, and port channels. So here's what I'm going to do with it. And I'm going to open up a Jinja 2 template. Okay? So let's look at the Jinja 2 template. that I'm going to build to start with. And you can see there's all kinds of Jinja 2 templates. Show interface. And it's a skeleton version. I have this offline stored as like a template for the templates, if you can believe it, right? But yes, so here I have this loop set up, or a condition set up, that says if the file type loop is CSV, and then I have a blank space, if it's Markdown, well, I have a header, and then 3 rows with pipes. Else, meaning it's not Markdown or CSV, so it has to be HTML, right? Build the outline of an HTML page. So follow so far? Now that's my skeleton, and what I'm going to do is I'm going to look over these fields. First, I'm going to have an outer loop here that says, right, for interface in to parse interface, and I'll show you where that comes from. Keep that in mind. You're going to say, where does this come from? This to parse interface is actually in the Python, and we're going to come to the Python at the end of all this. I've thought to work backwards, and then we'll get to the Python. But in Python, what I need to do is pass the data on the right, this JSON, feed it into, right, connect it to the Jinja 2 template via the Python. And this is my anchor point. So I'm going to say for interface in to parse interface, and that's going to loop over, in this case, 1, 2, 3, 4, 5, 6 interfaces. Now, I have to, and you're going to see, why did he go down a line? Give me 1 second. I'm going to have to end this for loop to close it. All right. Now here is my header row, and I'm going to have interface colon, comma, and then in here I'm going to say interface, comma. So far so good? So I need a header row, my row of headers in my spreadsheet that are columns, and this is a column I've built in CSV, referencing this outer, right? So the first time through this loop, this is going to say Ethernet 111. Then I fill in the rest of the template, right? So in this case, I want to have interface, and then in Markdown, I need to tabularize that with a delimiter, and then I just simply take interface here, place it between those pipes. And now what's the HTML version? Well, the HTML version is open and close tags. So I want to have my header row inside of this row, table header, and this is going to say interface. And then I close that tag. I go down into my body, and here, by the way, I need to, let me come back to that. I need my table, the actual interface, and then close that. Now I have to right, I can't forget to make these for loops here and here, and then I have to close those for loops, right, here and here. Now that will give me the interfaces in one column in a Markdown and an HTML table in an HTML page and a CSV file. Now I'm going to spare you the trouble of me templating all these fields, but that's what I'm going to do, is to complete this template. So now let's take a look at the, and I'm going to save this and come back to it and time lapse it for you. Let's come back to how this is done Pythonically. All right, so I have two files here, and you'll notice I have my main NXOS Merlin files. Well, what I've been doing is I have a one job, which is one at a time, and the job file is the PyATS job framework, which then loads the raw 1.py file. So how is this done Pythonically? Well, I import the things I need. I need YAML, because I want a YAML file. I need JSON to work with the JSON. I import some rich to make the ASCII colorful. I import the AE test framework from PyATS so that I can set this up as a series of step Boolean-based tests. I import topology so I can test against multiple devices in my testbed file. Remember, we use the testbed file to connect to these devices with the credentials and the IP information in the testbed, as well as some flags such as platform and OS to indicate this is NXOS and that it's an N5K, for example. Then this is from the community. I can't take credit for this. I had written this. I'm a bit of an old school developer, and C++ is object-oriented, and Python is object-oriented. But I hadn't really written this because I'm still learning Python with you and openly learning it. I hadn't really written this code originally that object-oriented. And what the member of the community was able to do was to show me that anything that we repeat often enough, right? Dry. Do not repeat yourself. We just want as little code as possible. So we have this general functionalities, and in this case, I'm parsing a show command. And I am parsing like 25 show commands. That's a great opportunity to make an object, to make a function of your own, instead of repeating all that code. So there's actually a couple of functions I'm going to show you. First is the parsed show command, and if we go, I'm going to split screen here and go to the general functionalities py file. Well, here we have a class where we define this function here, parse show command function. And steps.start is the PyATS starting the test steps. And it's been turned into a function where we do device.parse and then the command name that we feed in over here. So here's what it looks like. Remember, I said that it doesn't work on the Nexus 5K, so I just filter that out. Don't waste the time and the CPU cycles of running the command and for it to fail. So then I set up a variable, right? Left side of an equal sign in Python is me defining self.parsedShowInterface. And here you can see parseShowInterface command function. Here's the connection. Here's the connection. Let me try to put them close to each other, where I'm feeding in show interface into this function. Now, I'm doing them one at a time here, but if I show you the main Merlin, the reason why that's done is to reduce the amount of code, right? So here are my learn as functions, and then here's all the show commands as functions. Just one line per command, right? So let's dive deeper into this and I'll show you what I'm doing here. So again, I'm stashing, as of here, as of line 82, self.parseShowInterface contains all that JavaScript I showed you earlier, right? As an anchor point, let me show you as we go, because that's what Genie is doing for me. The software development kit is taking that standard CLI output and turning it into this. So all of this stuff in this file is stuffed inside of this variable called self.parseShowInterface, which then I am going to say, okay, if it doesn't equal N5K, and if it's not none, I just another check here to see if that variable's not empty, right? Go ahead and do the following lines of code, and it's pretty efficient code. So first we have to define our template. And again, at this point, these are all left side of the equal sign. So we're defining these three variables. One is going to hold that J2 file that we were working on to make the one column of interfaces in our three files. You follow so far? Now, we set up the directory name and the file name so that we can pass them to these functions that save to the JSON file calls it down here, saves the file with the file name and the directory and everything that we want, right? JSON.dump content, and the content is the, right down here, the self interfaces. Then we enter a loop here, and I'm just going to make an anchor point here. Up top, I have file type loop, where I have my CSV Markdown HTML, and to anchor that into a template, right, if file type loop equals CSV, meaning we're on the first cycle through the loop, template the CSV version, right? So then this calls the other template down here, and we make, here is the dot render is the key magic to this whole thing, right? So make a new variable called parsed output type, and that's what we're going to save in each of the 3 files. As we loop through, we render, passing in, there's that 2 parse interfaces. Let me show you the anchor point again, because we haven't talked about that in a while. But here in my loop, this is what I'm passing in, which is the JSON representation. Then we render it through Jinja 2, and we get our 3 files. Great. Now, these last step here, let me get out of that application. I don't know why that's even running. Excuse me. So the last step, again, one of the files that I'm creating is a Markdown file. So in that folder, if it exists, if this all worked, right, first check if this Markdown file, show interface Markdown, exists. And if it exists, run it through the markmap command and create the mind map HTML representation. Now, as you can see, at this point, I do not have the network JSON graphs as part of these templates. I build, this is a live development video. So I build on my success. So once I have a working CSV file and Markdown file and HTML file, I then go further and make a network JSON graph, which we'll come to later. So that is Merlin in the data center, and for the show interface command on NXOS. So if you could visit Automate Your Network on github.com/Merlin, the README file is all here. It explains everything. It shows all the file types and how this all works. And I would love it if you could give me a star, give me a follow. Go ahead and fork the repo and try this in your data center. It's going to work, I hope. That's the best I can hope for. Now, on that topic, someone's opened an issue, and let's talk about what issues could arise for you in Merlin, particularly with interfaces. Let's say that tunnel interfaces is something you have in your data center, and they have a weird field that's not part of my current Jinja 2 template. Or, right, it differs some way from the template that I've provided the community. It may fail. And what you can do is, here's what I recommend you do in that case. You find the Jinja 2 template that's failed, in this case show interface, and you just delete everything inside the file. Don't delete the file. Empty the file. Make the file just an empty file. Everything will run to completion then, and you will just get empty CSV files or whatever, right? CSV Markdown HTML. You won't get a mind map. You won't get a network graph, which is okay. But what you will get is the JSON version that you can then send me the snippet or the, right? You could find that tunnel interface key that's not in my template and patch it yourself with a pull request, updating the logic in the Jinja 2 template. Or you can just open the issue, and if you provide me the stanza of JSON that didn't work or tripped up your run, I can patch it in myself. So I'm just going to stop the video now. I'm going to finish templating out the CSV Markdown HTML. And when it's complete, I'm going to show you what these reports look like. Then I'm going to start templating the network graphs, finish that, and then show you what a network graph looks like. Okay, all right, so we're back. And what I've gone and done is finish templating the CSV file portion of the Jinja 2 template. Now, I got to get the whiteboard out for this. Now, this goes right per device, per interface, regardless of type. This could be right a physical interface, an SVI, a loopback, a tunnel, a port channel, a sub interface. It could be many different interface types. And now how many pieces of information do you think we get out of this parsed command in JSON? 10? Is 10 enough? It's more than 10. 20? No. 50? Even more. 80. We have 80 columns, right? I'm making a spreadsheet and it's going to look like this, right? A grid. Well, we have 80 columns. 80 columns of information per interface if all of those columns are present. And we have the logic in there to just put NA, not applicable, if any of these individual fields are not valid. So let's take a look at this. So where we left off, and you can still see that the Markdown section here and the HTML section here still only has interface, the singular variable. Well, I've gone ahead, like I said, and have 80. Now let's just drop this one down so we can examine one of them and how I do this at scale. Right? So let's isolate this one. So first I check if it's defined. There's so many combinations, right? Interfaces might not have a description. And I don't want it to fail or bomb or leave just an empty gap in the spreadsheet. So let's check each one of these 80 fields. And if they're defined, then go ahead and plug in the data into the Jinja template for this interface in the loop for interface into parse interface. Else, right, if it's not defined, then just hard code not applicable into that field. Right, and we just do this on and on for each of these 80 columns. I'm going to throw this away. Now I've run this and it takes again 1.4 seconds, everything passed, and then I do my get stuff and push it back up into the repo. And let's take a look at, the one of the 9Ks. Now what I like to do is go right to the bottom here and look at, so on this Nexus 9K, there's 178, right, total minus the header row, interfaces. And I have 80 pieces of information that I like to use them this way. And I can sort them or filter or find, let's say I'm only interested in the SVIs on this device. Well, I can uncheck all and then, right, look at all these interfaces and then go to the VLANs that I'm interested in if that's how I want to filter it, right? Or I want all of them again, but I want to sort them by the admin state. Or I could filter out anything that's not applicable or down and show me only the up interfaces. Any which way we want to slice and dice it by any one of these columns, right? So if I go to the end into the counters, right, here's CRC errors. Do I have any? No. No, I'm free of CRC errors. I'm free of discards, right? I can quickly check in here. Yeah, incredible. I can sort them by, which interface has the most input multicast. Well, I sort them by multicast, and it's this interface, which happens to be, a port channel, which has the VPC peer link. Pretty neat, right? There's the bandwidth if I want to sort them by bandwidth, the port speed, IP address if it has one, right? All this rich information. in 1.4 seconds at scale. That's one device. I have it for 2 devices, and I also have it for the 7Ks. And as you can see, it's platform agnostic. It doesn't care if it's a 7 or a 9. I have all of this great information. So what's next? Well, let me show you what I do next. A little bit of it. It takes a little bit of time, and I don't want to draw this video out. But I go back to my show interface. And this one keeps word wrapping on me. Okay, so now here in this, right, this is where I want to put the markdown. So what I'm going to do is simply take the whole row. Oh, it doesn't. Something wrong with the word wrap. Yeah, on this one. This file's got a problem with VS Code. I'm going to actually have to word wrap it. Yeah, I don't know what's going on here. So anyway, I'm just going to take all of this, maybe because it's just too long to display horizontally. Probably. I'm going to take all of this to here, to the end of the for loop. I don't need the end for, right to the end of the last cell. And I'm going to copy all that. And then I'm going to replace this section here. And I'm going to put one space pipe at the end. And if I can find the start, go to the start and put a pipe space. Now, all I need to do, and this is going to happen, a lot, is do a find and replace on the comma and make it space pipe space. And I'm just going to do that. Now, I'm going to come back to the main screen here. And so I replace all of those commas and make it Markdown ready. I do a similar thing with the table and the tags in HTML to make my HTML page. So this is going to take me a few minutes. I'm going to finish this work and get my 3 file types. I'll show you what the other 2 file types look like. Plus the mind map, which is just, it's going to be so ridiculously huge it might not be usable because of 178 interfaces. But I'll show you what a mind map of this interface set looks like. And then I have to work on the network graph JSON. Okay, stay tuned. I'll be back. All right, so here we go. I'm back again, and I've finished out the templating. So let's switch over here. And this is what the final template looks like, where you can see I've gone ahead and I've done the markdown section accordingly. And then here, I don't have to do this. I could leave it, horizontal, but this is a nice way to look at it. So all of these are table headers for columns in an HTML page. And I mean, look at them all. Look at all these fields, right? 80 of them. And then we have our logic, right, which checks if they're defined, and then goes ahead and plugs them in or puts NA in. Now, some of these have compounded logic, which you can do in Jinja, such as if, port channel and port channel interface are defined. So if those 2 fields match, then go ahead and treat it as a port channel, right? So we get all our counters and then some other fields. And so let's see what this looks like. I've gone ahead and already compiled these, and we've seen the spreadsheet. Now again, the spreadsheet is the most valuable file, but I do these because I already have the data, and it's just a matter of copy pasta. And so let's look at the markdown file. Now this is going to be unrendered. Let's give us some screen space here, but I can render it in a preview. And this is, right, we get a markdown file with all 80 fields. And I can't search, or I can't sort, but I could search and find. And this renders nicely in a GitHub repository, like the README file is written in Markdown. So then we have the HTML. And again, this is what it looks like unrendered. And we have each, all this for each interface, a table row. So let's go ahead and see what this looks like. I already have it open in the browser. And, with the style sheeting, this is what it looks like, right? So again, it's like the markdown file, but it's a little more colorful. And I could have things like if this is down, I could change this cell to red or whatever. And then we also have the mark map from the mind map from the markdown, which we can zoom and collapse and do different things with. Now, this is such a large data set that this is not the most useful file. I mean, there's hundreds of interfaces, but I render it anyway. So that's the tour so far. I'm going to try to work on the NetJSON next. Now, you need a super powerful computer and a big screen to really appreciate the NetJSON, and it's going to be just insane with all of the different interfaces that we have. So again, it's an experimental file. I like to build them because, like I said, I already have the JSON. It's a couple more templates. I don't mind doing it, and some of them are pretty neat, and we'll see what it looks like. It's just going to be a mess of dots and lines, but let's take a look. If you had a smaller set of interfaces, 48 interfaces for example, it might be a little more useful. Or I can toggle it to say, and that's what I'll likely do, is add a toggle to say only render interfaces that are up, or have an operational state of up, because I don't want all of the other interfaces on the network graph. Let's make a graph of only interfaces that are up. But there's so many fields, I'm going to have to pick and choose. I don't know if I want all of those counters, for example, on the network JSON graph. So I might do a smaller subset of data, the relevant fields, and make a network graph that way. Stay tuned, much more to come. Thanks again. Okay, welcome back for the last time. And I'm here with the network JSON graph. Now I just want to highlight that this network graph is, as Ethan Banks put it from Heavy Networking, we did a little bit of this together. It's experimental, right? And that's what it is. It's an experimental format that I think it's great for small data sets or things of that nature. Once we get into hundreds of interfaces, it's pretty wild. And the computer that I'm rendering it on, it's just a little jump box. It's not meant to be a high performance video rendering system, right? But it'd be interesting to see what this would look like on a system with a high graphics card or whatever, right? Like I can render these pretty quick on my own personal computer from the DevNet sandbox. But anyway, let's get into it. And let me just get the screen going again. And so in the Python, I've added two new variables here, which are two new templates. And one is the JSON format, and then one is another HTML page that I'll show you the templates and then the rendered versions of these. And then there's this whole new section of code here where we render and render, right? And in the JSON, I need the JSON passed in, but in the HTML, all I really need is the device alias. So then I save it as a JSON and I save it as an HTML depending on the parsed output, which gives me my new files. So let's look at those templates and then we'll look at the files. So here in the repository there's two new templates, and I'll show you something here. I've called them connected. Now this is the HTML page where I'm calling the style sheets, and this D3 min.js, this was open source. I did not write this. This is from the open source community, as well as the network JSON graph JavaScript, both from netjson.org, I believe is where I got these from, the open source, where we use d3.netjson graph, and I feed it the JavaScript object notation that I've templated. Right? So now this is the template that creates the JSON. So this network graph has a concept of nodes and links. And if you want a link between two nodes, right, you have to define the node. So all I do, I don't want to say all I do, but what I do is I take the HTML. These are very close. Let me call up, right? I go to the bottom of this file, and I take the HTML, just let me get there, this here, I take this HTML at the bottom, and I copy it into this file in this structure, right? There's the for loop, for interface, and I add the if the .opera status is up. So filter this down to be just up interfaces. There's already enough interfaces in here. Let's filter it down. Now, you're going to see me set a loop variable here. I'll come back to that. That's important in JavaScript object notation templating. If you're making a template of valid JavaScript object notation to render like I'm doing in this case, or to post it to an API, well, you have to track the loop because, and I'll show you this at the end. We'll come back to that. So then in the nodes, it's an ID, and for some of these, I give them, like description and MAC address, and then the variable per interface. Now back to that loop tracking. Now what I do is the last entry, right? Let me give you a little bit of white space here to see what I'm talking about here. This is the last entry, and I always pick something like it's for interface, and I know there's going to be interfaces. I don't use one of these variables that may or may not be defined as the last variable in JSON, because I need to know that it's going to be there, because I need to track whether or not you can see if I'm on the last interface in my big loop, then don't put a comma here after the mustache, after the curly brace facing right. Right? We don't want a comma there because it's the last one. Else, well, it's not the last one, put a comma. Okay, so that's why we track the loop. And if I had nested loops, I would have to track those nested loops depending on which loop is the inner or outer loop. And sometimes you need compounded to say if I'm on this and this, make sure that you put the comma. And then the links is pretty interesting. You have your source and your target, and you basically choose the hierarchy how you want these JavaScript object notations to be linked together. So what I do is at the bottom, right, the last one, I have the parent linkage to the device alias, and then the interface. And then every other key value, in this case, spiders off of that interface, so we make a graph out of it. So what does all this look like rendered? I don't want to save anything there. Well, let me show you what it looks like rendered. Now this is the HTML page. Let me find that first. This is the presentation layer, and it's very simple, but it's plugged in the device name, and this is the page that I'm going to show you. And then there's the JSON, and this is what it renders. And you can see that this didn't turn red. VS Code is very sensitive about bad JavaScript, so watch. If I delete a comma, it turns red. That's not a valid file. That will not render, right? So I know that that's a good file. So great, what does it present as? Now again, I'm just going to show you what it looks like. Okay, so this, and I'm going to zoom out even more, is the JavaScript, the network graph. And you can see it has 1,100 links. This is a monster because it's show interfaces. But if you were to look here, this orange dot here is the MTU. So everything that shares the same MTU gets a link to it. And eventually they all link back. One of these in the middle is the core device. And then you can see different shared objects. And then all the spokes, like, this is an IP address here. I don't think it even has the power to let me move this around. This whole thing is dynamic and interactive, and you can zoom, but it's just too much. I'll show you a different one, a smaller one, in a different video. But anyway, I know it works and I know it renders, so I'm just going to collapse that and close everything here and come back to my main screen. So, right, we want to connect to the devices, single device, multiple device, doesn't matter, 7K, 9K, both work with this particular command. Run the command, get the JavaScript object notation, turn it into 7 different file types that we've seen. The CSV file is just 80 different columns of sortable, searchable, filterable data. Your interfaces in a pre-canned, ready-to-go spreadsheet. It's open source. It's ready for you to clone. It's ready for you to run. As soon as I release it, obviously I still have about 15 commands left to do to go through this process I've shown you. And if I find other commands or as I go, I may make other videos. But for now, I'm going to just keep plugging away. Find me on Twitter, John_Capobianco. Find me on automateyournetwork.ca and find this GitHub repo under github.com, automate your network, Merlin. Happy automating in the data center. Have a great time with this, and let me know if you have any questions. Take care.